All right, welcome back to The Explainer. There's this term that is just everywhere these days. It's one of the biggest buzzwords in tech, for sure. I'm talking about machine learning. We all hear it, but what does it actually mean? Well, today we're going to pull back the curtain and figure it out together. Let's get into it.
So, let's start with something that probably feels like a little piece of modern magic, something you likely use every single day and don't even give a second thought to.
I mean, really think about it. You can scribble a note on your phone or your tablet, and poof, it just magically transforms your messy, unique handwriting into perfect digital text. How on earth does it do that?
It really does seem like a magic trick. But here's the secret. It's not some programmer writing millions and millions of lines of code to account for every possible way a person could write the letter A. No way. The secret is that the computer itself has learned what an A looks like. It's learned an entirely new skill.
Okay, so this whole idea, a computer that can actually learn, it's not just a cool concept. It has a real name and a fascinating history. Let's dig into where this all started.
And you might be surprised to hear this isn't some newfangled idea that just popped out of Silicon Valley a few years ago. Nope. The term machine learning was actually coined way back in 1959 by a guy named Arthur Samuel, a real pioneer over at IBM.
And what he said back then, it's still one of the best definitions out there, just so clear. He described it as the field that gives computers, and I quote, the ability to learn without being explicitly programmed. Just let that sink in for a second. That's the whole game right there. It's not about a computer following a rigid set of instructions, it's about it gaining a new ability all on its own, through experience.
Okay, so if the computer isn't just following a long list of pre-written rules, how does it actually learn? Well, it turns out there's a pretty straightforward framework for this, almost like a recipe.
And the formal definition is, believe it or not, super simple. A computer program is said to learn if its performance at doing some task gets better and better with more experience. That's it. It's all about improvement over time.
This whole recipe breaks down into 3 key ingredients. You can just remember it as T, P, and E. The task is the job it needs to do. Performance is how we grade it, how we measure if it's doing a good job. And experience is the data, the examples we feed it to learn from. This is basically the blueprint for teaching a machine to do just about anything.
So let's bring this back to our handwriting example. The task, the T, is pretty obvious, right? The job is to look at a bunch of pixels and correctly recognize and classify them as handwritten words.
Right, next up, P for performance. How do we know if it's getting better? Well, we measure the percentage of words it gets right. It's that simple. If it starts at 80% accuracy and after some training it's at 95%, well, congratulations, it has learned something.
And now for the most crucial part, E, the experience. In this case, it's a ginormous dataset of handwritten words that humans have already labeled with the correct answers. You can think of it like the computer's study guide, just thousands upon thousands of examples with the answer key right there.
Okay, so having a study guide with all the answers makes a lot of sense. But what happens when there is no answer key? What if the computer has to learn without any answers at all?
And this is where things get really wild. What if you just hand the computer a massive, chaotic pile of data with 0 labels? No, this is a cat. No, this is a dog. Can it learn anything useful from that? And the answer is a huge yes. It's a whole field called unsupervised learning. And just like the name says, there is no supervision. The goal isn't to be correct because there's no correct answer to check against. Instead, the goal is for the machine to just find interesting hidden patterns all by itself.
So now we've got these 2 very different ways a machine can get smarter. 2 totally different paths to intelligence. Let's put them side by side and see how they stack up. So here's a great way to think about it. Supervised learning, our handwriting example. That's like studying for a test with a teacher. You have labeled examples, you have the answer key, and your goal is to predict the right outcome. But unsupervised learning, that's like being an explorer, dropped in a new land. You have no guide, no answers. Your goal is just to map the terrain and discover the underlying structure of this new world. Let's make this super concrete with a classic example. Imagine we give a computer algorithm a giant folder, just jam-packed with photos. Some are cats, some are dogs. But here's the catch. We don't tell it which is which. There are absolutely no labels. So what does it do? First, it just starts analyzing all the data, looking at the raw pixels in every image. Then it starts to notice features. It sees that some pictures tend to have pointy ears and whiskers, while another bunch has floppy ears and long snouts. And finally, based on those shared features, it just groups the similar-looking images together. It creates 2 distinct piles.
Now, it has no idea one is called cat and the other is dog, but it found the fundamental pattern in the data all on its own. Pretty cool, right?
So, to wrap things up, what are the big takeaways here? First, machines learn when they get better at a task through experience. Simple as that. Sometimes they learn with a teacher, that's supervised learning with labeled data, and other times they're like explorers, finding hidden patterns on their own, and that's unsupervised learning.
And that really leaves us with a huge, fascinating question to chew on. We just saw how a machine can figure out the difference between cats and dogs without any help. So, if they can already find simple patterns that we can't point out, what about the incredibly complex patterns that we can't see? What hidden structures in our biology, in our financial systems, maybe in the universe itself, are they going to uncover next?